My name is Carl Engström, although most people actually call me just by the 3 letters of my surname, which is Eng. I was lucky enough to join Spotify at a time where that was actually an available username, so I am now, as my email states, eng@spotify.com. I have the title of senior developer, but what I like to say that I do is that I'm a backend developer, because that's what I do. We write all our backend services in Java, and we are pretty much a Java shop in many ways, with Android code being written in Java. iOS is a bit of an exception, because we have to use Objective-C or Swift to build our apps there. And actually, for those of you who are here for the first talk, we actually have Scala as our official language for our data processing pipelines these days. Some people get a bit confused when I say that I work for Spotify in Gothenburg. They're a bit surprised that that even exists. So I just wanted to say that we do a lot of stuff here. Any type of playback that you hear, so actually playing audio, or playlisting, or any form of saving that you might do within the app is something that we take care of here in Gothenburg. We do that across the entire spectrum. So we're a cross-functional office, so we have everything from mobile devs to backend devs to data engineers and so on. We're growing all the time, so if that seems like an interesting thing for you, let me know. I absolutely love the topic of failure. That is one of the most interesting topics in software that I know. And that might sound a bit strange. Sometimes I will say things like it's good to fail, or we should get better at failing, and people can read a lot of different things into that. So what I just wanted to say is that when I say that you should be good at failure, I don't mean that you should fail more. I mean that you should fail better. And the way I'm going to try to sort of unpack all this today is I'm first going to talk a little bit just generally about like failure and humans and how that sometimes isn't a great combination, how some of the things in our brain make it a bit hard for us to understand if and when we fail. And then the majority of the part I'm going to spend telling a story of a failure at Spotify that happened a couple of years ago. And it's a story that I am very familiar with because it was I who caused this incident. So I have first-hand experience of what it's like to produce a rather big failure at Spotify. But before we jump into that, the keys to sort of being good at failing is that you want to end up in a state where you are prepared. So if something happens, you have an idea of what to do. And then even though the failure in itself is probably a negative event, like something that you didn't want to happen happened, you can still make something good come out of it by making sure that you learn. And the reason why I put that on this sort of agenda slide is because that's pretty much what I expect from you during this talk. Because I think that software in general, we talk way too little about failure. So we talk about why this framework is so good or why everybody should do this thing, but we never, or rarely at least, say, here's what we did and that did not turn out so great. There are a few of those stories around, but they usually end with like a positive twist. Here's how we did this and it went bad, but we saved it. But an interesting thing that I always found is that if you, after a conference like this, you go to, say, the Bishop's Arms and you drink a few beers with people, they start telling slightly different stories. They start telling the failure stories where things maybe didn't go so well, or where, you know, we implemented this new thing and it was okay, and now we're sort of stuck with it. And I think those stories need to be shared as well. So this story is a bit like that. It doesn't have that nice kicker at the end. It doesn't, you know, install this framework and you will never fail is not going to be my final slide. So in order for you to get the most out of this talk, you actually have to be a bit prepared and make sure that you learn. So as I tell these stories, ask yourself, like, what would have happened if this was our organization? How would our company have solved this? What would my team have done? Are we prepared? If you ask those questions, I think you'll get the most out of this talk. So, speaking of questions, I'm actually going to start by asking you a couple of questions. So I want you to raise your hand and keep it up if you work with a system which somewhere has a database, which has data in it, that is considered important. And definition of important, like if your customer or maybe your boss would be upset if you lost this. So that's quite a few of you. Keep your hands up. My next question is, keep your hand up if you take regular backups of this system. By regular, I mean like on a cadence, not like when I remember to. Okay, that's most of you. And then the final question I'm going to ask, keep your hand up if you have confidence in those backups. So that's pretty much all of you. Thank you. You can put your hands down. So I'm going to start this with a story not from Spotify, but from GitLab. GitLab, just to be clear, I think are tremendously good at failing. So this is not an ironic story. I truly loved how they did this, and the fact that they released this postmortem publicly so that everybody can read it is perfect. If you haven't read it, please do. It's fantastic. Just Google GitLab postmortem and you'll find it. But I'm going to read you some key things that I took away from reading this postmortem. So just to sort of set the scene, what happened at GitLab was that they had two databases. One was the primary and one was a replica. So they were already prepared that one of them could drop at any time. But the replica had been struggling and had actually fallen behind in the replication. And after a while, it had fallen so far behind that the master was sort of assuming that this must have been replicated by now. So it started deleting the files that the replica was supposed to download. So the replica basically died. And that's where this incident started. Now, this is not the end of the world. GitLab were prepared. And the thing that they decided to do was if they would delete everything on the replica, then that replica would actually start like a full synchronization of the database, and it would come back up. So that was a pretty good plan, actually. The problem for GitLab was this. Trying to restore the replication process, an engineer proceeds to wipe the PostgreSQL database directory, errantly thinking that they were doing so on the secondary. Unfortunately, this process was executed on the primary instead. So rather than killing things on the replica, they killed the master. And now they have a big production incident on their hands. But once again, GitLab are prepared. They have not one, not two, but 3 backup systems enabled for this, because this is their most important database. So they go to the first system. When we went to look for the pgdump backups, we found out that they were not there. The S3 bucket was empty, and there was no recent backup to be found anywhere. So that's the first backup system. Gone. All right, well, they have 2 more, so this is the problem. The second was snapshot of the machines. While enabled for the NFS servers, these snapshots were not enabled for any of the database servers, as we assumed that the other backup procedures were sufficient enough. Second backup system, not even online. Well, okay, that's fine. They had a third one. To recover GitLab.com, we decided to use the LVM snapshot created 6 hours before the outage, as it was our only option to reduce data loss as much as possible. So at this point, with the third system, they have to face that they lose, not only are they having an outage, they're going to lose the 6 hours that they had before the outage, but at least they'll get back online. What was the purpose of the LVM sort of backup? Well, its primary purpose was actually to put data in their staging environment so that they can test stuff out before rolling it out to production. Well, that also meant that it was actually in a different part of their cloud provider, in a different zone. So what they learned as they restored this was that copying the data from staging to the production host took around 18 hours. So GitLab, a place where people are really good at failure, had a primary, a secondary, 3 backups, and they found that the first backup was broken, the second one wasn't on, and the third one was untimely. Dealing with failure is actually a lot harder than you might think. So at this point, I'd like to ask 2 more questions. For all of you working with databases, put your hand up if you know of someone who, in the last 6 months, actually restored a backup. Not as many. For all of you who had databases, how many of you now have confidence in your backups? Not as many. For those of you who do restores, fantastic. You are doing great. So this thing that just happened is a really interesting thing. We have a tendency to make some assumptions as humans. One of those assumptions is that when I ask you if you have confidence in something, you ask yourself the question like, do I believe these backups? Will they work? And what you actually end up asking yourself is, can I remember a time when they didn't? And if the answer to that question is no, then we believe that they work. The fact that you can't remember a time where they actually worked seems to sort of fall out of our heads. So as a rule, which GitLab learned this very sort of public and hard way, is that the absence of failure does not mean the presence of success. So unless you see something working, maybe consider the fact that it doesn't work. Why is this important? Well, I think you understand, but actually, it all comes down to this question, and this is a question I'm actually asking you to think about. How do you know when your code is failing? And this is not a typo. It's not supposed to say if your code is failing. It's when. At some point, whatever you call production is going to break. How will you know? And if I was going to express how I see a lot of organizations dealing with failure in code, I would express it like this. This is perhaps not how we write the actual code, but what we do is we do a thing, and then we assume that it sort of went well. And if it didn't, well, if we don't look for it, then we might never find out that this thing actually didn't work. So I'll give you a more concrete example. Let's say that you're making your next release for something. I think most of you do some form of regression testing, but I think you also might want to spend as little time as possible doing regression testing, because that doesn't feel valuable, right? You want to get it out. I now have to authenticate to the network. Let's see if I can ignore that. So where was I? Regression testing, yes. So we try not to do that. And the other way that you can discover an error is perhaps that your customers had that error and they sort of tell you about it. And then you can ask yourself, how easy is it for them to do that? Do we have like regular sessions where we have chats with them where they can tell us what's going on? Or do we have like a support system in between where it takes us a couple of days to even answer a ticket? And if you look at those two things, you can actually start to figure out like what is the quality of our product? What kind of bugs will we catch? Well, we will catch the bugs that we see in regression testing or that are annoying enough for our customers to tell us. And then you can ask yourself, is that good enough? And that's the sort of next best thing. When you know what failures you have, you can start asking yourself, are we okay with that or are we not? Now, I purposely put this as code because I wanted to anger some developers, because this code, I think in most of us, invokes a feeling of like, no, I would never do that. What people very often do, though, is this. And they say, look, I do care about the exceptions. I've logged it here to a file so that I can look. And I ask them, okay, so what does the file say? And they are, sometimes IO exception, sometimes database locked, sometimes null pointer. And I say, yeah, but what does it say now? And they go, what do you mean now? I said, today, this hour, this minute, what does it say? And they say, I don't look at the log now. I mean, if something goes wrong, I'll go to the logs to see what happens. Yeah, well, now you're not telling me how you detect that a bug is. Now you already know that there's a bug. So that's another question that I think you should really take home. Like, how do we know if our product fails? Or when our product fails? See, not even I can do it. The truth is that you will only ever fix the bugs that you know of, and this is what I was hinting at before. Your quality will only be as good as what you can see. Anything beyond what you see is guesswork. And if you don't actually know what your product does when it's out there in the wild, you're guessing. And the sooner you can come to terms with that and start doing something about it, the better. So I will now start to tell the story from Spotify. And once again, just as I go through with this, ask yourself, how would we have handled this? Would we have noticed this error? What would we have done? How would this have worked? And afterwards, or at the pub, tell me not just the stories of how you think you can improve, but also how we can improve. We're far from perfect. So if you see something that I didn't talk about, let me know. If you are serious about failure, you're also serious about getting better. So this story revolves around a service known as Social Graph. And Social Graph's purpose at Spotify is that if you go to an artist page or to a user page, this is a button that says follow. If you click it, it says following. Social Graph is the backend service that keeps track of that. That is all it does. That's its only purpose. And if I was to describe Social Graph, I'd say that it is no one's favorite service. It was written by a new team in a new office with really tight deadlines. The result, I think you can sort of imagine. It was then passed around the company for a while until it eventually ended up with my squad, and we've owned it since. So what happened? Well, what happened was that the slides don't work. Oh, okay. Not sure why that worked. So this service used memcached, and we had replaced a library known as spy-memcached with another library known as Folsom. That was it. It was super simple. They're just two Java libraries for talking to memcached, nothing fancy going on here. And when we rolled out memcached, we looked at our graphs. So at Spotify, we measure a lot of things around our services. So for example, we measure how many requests we get, how long it takes to respond to those requests, what type of replies we give back, the status codes. This graph, which I've shown here, which is sadly not from the actual incident, shows us the error reply ratio. This is the percentage of responses that are failures from a certain backend service. And what we noticed when we rolled this out is that after the rollout, the failures started going up. Not much. So these are also values that we go on call for. So if they go above a certain value, we will get paged. But they're also good to look at during a deploy to see if that deploy actually did what you thought it did. And there was no good reason why we would see an increased number of errors just because we switched the memcache client. That's a technical detail. It should not affect any end user. So we decided to go digging. It turned out that when we created the key, memcache is really just a key value store. When we created that key for users, it would contain their username. This is a bad idea for many reasons, and we've changed it since. But in this particular case, it was bad for a very specific reason. And that is that, I don't know, these days, when you log into Spotify, you do it with an email address or something like that. But back in the days, people got to pick their own usernames. And our username policy, I believe, is designed by engineers because it manages to be very restrictive and very sort of open at the same time. So to give you an idea of what I mean, we don't allow uppercase letters because that would be too much. But this is a test user that I follow. This is their actual username. So as you can see, a lot of the control characters for like HTTP and stuff, they go in here. That's fine. And for those of you at the back who are not sure what you're looking at, this guy here, that's the UTF-8 symbol for snowman, which is a perfectly valid Spotify username. However, it is not a perfectly valid memcache key. And what we found is that the old library, spy memcached, would treat this like a cache miss. If we attempted to set a key that wasn't there, it would just ignore it, whereas Folsom threw an error. So we had found the cause of the error. Now we could reason about the error. Is this an error that we're okay with? Not a lot of users were affected, but the ones that were affected, they would lose a feature. We can't have that. So no, we can't allow this error. We have to fix it. So that's what we set out to do. Turns out that since we already knew that usernames as keys were a bad idea for many reasons, we already have this sort of internal, let's call it a function, which I'm just calling resolve ID here. So what we had to do was just take this code that talked to the memcache client, and instead of creating this cache key using the username, we would cache it using this resolved ID. And these IDs are known to be well formatted. They're basically just hex characters. So this was a fairly easy change. So we did this change to the client class. Wherever we saw username, we would wrap it with the resolve ID username. And then I thought, okay, this is good. So the next thing that happens to us to sort of try to not fail is that we run the unit tests. I don't think this comes as a shock to anyone. And they all failed. Or not all of them, but all of them that had to do with memcache. This was a really good thing because the unit test looked a lot like this. So they would first set up a mock using Mockito and then verify that certain invocations were done. And as you can see, we're using the username here, not the actual ID. So it was very easy. We just sort of copy-pasted in this resolve ID function here as well, so that we would make sure that we validated that, yes, we now send them correctly. And there were lots of tests, so, but luckily all the test errors pointed out the exact row. They would fail here, and we would see, username, yes, let's just put that in, resolve ID. And then all the unit tests passed. After that, we have something called integration tests. I say we have something, not as though I don't think any of you have heard integration test before, but I found that people mean different things when they say this. So just for clarity, what we mean is that we start the service in its Docker container. In this case, it needed a Cassandra database and Memcache, so we started those in a container of their own. And then we fake any other systems that it talks to and our service discovery. So the service does not know that it's under test, and it has all the resources it needs to run. And then we send requests to that service, and we validate that those requests actually return what we thought. So it will do the whole thing. It'll write to Memcache, it'll write to databases, and so on. These tests passed out of the box, and that's really the important bit here, because by separating unit and integration tests, we have allowed ourselves to notice if we do changes to the API. If these tests would have passed, I would have changed the API. And that's not what I wanted to do. I wanted to change an internal thing. So that's really the important bit here. Separating unit from integration for us allows the unit tests to test the logic, the integration test to test the API. These passed. I opened up a pull request. There was a code review. It passed. It reran the unit test, the integration tests on a build machine. They passed. +1 merge. For most people, the next logical step is a staging environment. At Spotify today, mainly, we don't actually use one. As we've grown larger and larger, we've realized that the value of staging becomes smaller and smaller. It's hard for us to keep a staging environment that is representative of production. The only way I think we could reasonably do that today is to mirror production traffic into the staging environment, but that would be hugely expensive. So these days, the first thing after a merge is usually a Canary deploy. And once again, I think you know what a Canary deploy is, but I'll go through the steps just to be clear. So what happens with a service like Social Graph is that there might be, say, 20 instances of this running in a data center. And what we do is that we update just one. We give the new version to one of them. And then we observe that one. And remember, we have a lot of metrics for all things, so we can actually look, how does this Canary work in relation to the sort of normal services? And in this case, once again, I'm sorry this graph is from somewhere else, but you get the point. The errors dropped down to the level where we would expect them to be. In this graph, they're very close to 0. It's fantastic. So when we saw this, we even threw a few requests at it. We thought, okay, so our problem before was that the error ratio went up. We saw some things in the logs because we also have logs. And when we rolled this out, those things disappeared. We must have fixed the bug. So we deployed to production. Technically, the Canary is to production, but now it went global. High fives all around. Everyone super happy. You know that this is a talk about failure. I didn't at that time. What I didn't know was this. This is Liseberg's Valkyria, by the way. You should all try it out. I assume it's super scary. We were here. We had done all the nice bits, and now things were about to get really absurd. So what happened? Well, all the systems that I just went through, code review, deployment systems, graphs, those are the systems that would normally catch errors, and they have done millions of times. This time, we were on sort of uncharted territory because all those systems said, everything's good. So what happened was that I got a Slack ping from someone, and they said, hey, did you just deploy Social Graph? We're seeing some errors, and we're getting some reports of crashes on iOS. Now, just to be clear, they're doing this because they're polite. Our deployment system tells you who did what. The reason why they pinged me is because they know I pressed the button. They're just being polite. I know this. My gut feeling is to type no, because I know that this only happens on an error. But of course, I acted like a professional. I said, oh, that doesn't sound good. What kind of errors? And they do something fantastic. they sent me a link, like a request that I could actually do on my own client. They said, it seems that social graph followers count does not return the follower count in the response. Like literally the only thing it's supposed to do, it does not do. I took this command, I pasted it into my terminal, ran it, and sure enough, follower count is not there. I have no idea why, but it's not good. So I said, you're right, I'm rolling back. This is the being prepared part. Yes, we have a bug in production, but we can go back. I've seen a lot of people, they have a lot of ways of making sure that bad code doesn't reach production, but they have no way of understanding what to do if bad code is in production anyway. And here's the really weird part. Sometimes production will break without you deploying anything. So this is a really good case to prepare for. In our case, a rollback is just a deployment of an old version. So the first thing that happens is that the Canary gets this old version. So I take this exact same request, I send it to the Canary, I get the follower count back. So I now know that this is my fault. So I say, okay, it's definitely our fault. Not sure why. Global rollback is in progress. And they say, thank you very much. There's a lot to unpack here too. First of all, the thing that I did was not solve the bug. When something is bad, stop the bleeding. Don't worry about finding a root cause. Just make it stop. This is super important if you're prepared, because then users won't have this bug, but I still don't know what it is. If your way of fixing a bug in production is by releasing a new version, you first have to figure out what the bug is. You then have to fix it. You then have to ignore all your routines for how to deploy because you're in a rush, and then you're very likely to push something new out there. Instead, go back to a known state. But this, they knew. They had seen all the errors. They knew that things were going crazy, that this was not a good state. And yet they said thank you. They were polite. They helped me fix this thing. They gave me the command. They didn't shout. They didn't scream. They didn't tell me I was an idiot. They were polite. This is how you do incident management. This is fantastic. I can't show a bunch of developers a story about a bug without actually showing you what the bug was. So remember how I said that it was really easy? We just find this username thing and we wrap it in resolve ID and then everything's good. This is the code as it should have looked. This is the code that I wrote. So it takes a list of things to look up in Memcache. It's supposed to produce a map from those keys to a value, but it applies the resolve ID on the map that it returns, and it doesn't apply it on the thing that it queries, which means, no, come on. If you pass in the keys Bob, Alice, and Eve, you would expect maybe something like this. But in this case, what you would get is actually this. Now this might not seem like a big problem, or at least it seems like something that this would crash somehow. Like surely this would work. This would not work, sorry. Turns out that the people who wrote Social Graph, they had this wonderful idea that wouldn't it be great if the API for version 2 could be expressed as just one single object? Even though these are all the different types of responses that you can get, we would never return all of these at the same time. But wouldn't it be just sweet if we could have this as our object? And also with a constructor that creates the empty object, which doesn't make any sense. And then we just have this sort of JSON serialize annotation here, which means that if any of these get set to null, just don't write it in the payload. And then you can just set things to null that you don't want, and you can craft the different messages. This is a super dangerous thing to do, because now we have pretty much no way of validating whether a message leaving this service is actually correct. And what we did in a different place in the code was that we created one of these entities, and then we set the followers count. We looked up their username in the cache, but their username wasn't there anymore. There were other things. So when we did that lookup, the value became null. Yes, Scala, I see you. And so we would simply return the empty object. We would return a JSON object which contained nothing. But then you might ask, the integration tests, they passed. Everything passed. What is this? Well, if we go back to how this happened, we made the key using the old username, which means that if you were using a cache that contained the old entries, the key that we went from, they would be cache hits. We would get results back. But when we ran the tests, we used the new cache. So even though we put new things in the cache, we put them with the new keys. So the old keys were never there. Everything was a cache miss. We always went to the database when we ran our integration tests. And that's why we could only ever find this bug in production. These things don't make me happy, but they happen. We spent quite a lot of time on fixing that, especially since, even though all we had to do was resolve ID in the right place, we had just done a deploy where every single system had said that everything was good. But in fact, it was not. And I can tell you, if you're not used to having many systems telling you if a build is good or not, the only thing worse than not having this type of information is having it and not being able to trust it. Deploying something that you think might be bad, but your system tells you it's good, it's a really scary feeling. That was by far the scariest deploy I have ever made. But finally, we got that sorted. I sort of breathed out. It's all good. We had this on the Canary for, I think, 2 days, just to make sure that everything worked. We sent very specific requests. No, it's working. It's good. It's fine. We'll get there. And then I thought, crashes. They said crashes. This is social graph. It deals with followers. You can't crash on this. And to be more specific, they said crashes on iOS, like iPhones, but not Androids. Why is this? So I went to a client dev and I said, could you show me where we keep track of like the client crashes? Because similar things that we track for backend, we also track for clients. And he said, yes, of course, I'll show you. And he logged in and he opened it up and there was this list of issues sorted by number of crashes. And at the top, there was one that had like a little fire symbol on it. And he said, I've never seen that one before. My face went white, my heart sank, because the name of that one was Social Graph Manager. And I thought, oh my God. Luckily, this was a few days after we'd fixed it, so I'm glad I didn't see this as it happened. It turns out that just in the same way that Social Graph was nobody's favorite backend service, the Social Graph module in the client was nobody's favorite client code. And on iOS, it used JSON instead of protobuf. That's what saved us on all the other platforms. And it assumed that the fields that it expected to be there would be there, or else it would crash. And by crash, I mean the Spotify app died because you couldn't see whether you were following someone or not. And the number that was presented right next to that was this. So in about 15 to 30 minutes on the Canary and maybe 15 minutes in production, I had managed to crash 1 million Spotify apps around the world. And that was, in many ways, a really bad day and a really good day at work at the same time. And now we've reached that point that I talked about. There isn't a silver bullet. There isn't a framework. There isn't anything. I hope you tried to ask yourself some questions as you went through this. I love to talk about failure. So if you're going to the Bishop's Arms later, I'll be there. If not, my email is on the last slide. If you ever want to talk about these things, I would love to. There are some things that you can do, but most of the things need to be tailored to where you are as an organization and where you are with the code. But I love talking about those things. So if you ever feel that you want to talk about these things, please reach out. But if I was going to give 3 pieces of advice, like if you want to get better at failure leaving this room, my number 1 advice is start with culture. Remember that person that was polite. Remember the not screaming bit. Those are the important bits. Same as with the estimate talks, actually. If you introduce blame in failures, you're not going to get anywhere. People are going to hide their failures. You have to be transparent. You have to be allowing yourself to say, you know what, I messed up here. What can we do to make this better? Take one step at a time. I've seen a lot of people, including myself, who thought that their code worked, realized that it didn't, and then tried to fix everything at once. And that doesn't work. Ask yourself, like, what is the one thing that I can do to make it slightly better? The way you get to good quality is one step at a time. Tooling and all that stuff, you're going to get it, it's going to happen, but if you do these things, you're going to actually end up with the tooling that you need rather than the tooling that you thought you wanted. So don't run off and Google all the fancy frameworks that you think will save you. Culture and one step at a time is what will save you. The last bullet is for when you write code. When you have an incident or when you're debugging code or when you're just trying to understand what's going on, you're not as clever as you think you are. Which means if you were clever when you wrote the code, then you're not going to understand it in that case. So I cannot emphasize this enough. I tell this to anyone who's willing to listen and to a bunch of people who are not willing to listen. Try your very best to not be clever. If you can avoid writing fancy things, do it. Write simple things. Because those you can understand when they fail. That's all I had. My name is Eng. Thank you so much for listening.